So it's f of x, you're going to evaluate at a and b. So it's f of b minus f of a. Jack, put your phone away, please. If you integrate f prime of x, then you get f of x. Okay, Quinn, put your phone away, please. This is the only time. Look at how many days we have left. Not many. So you need to be focusing in class for that time, and then after that we can relax. Okay? That's the fundamental theorem of calculus. Maybe, maybe not. We'll see. What did I think I hear something? Now, how do you know if f is the antiderivative? F of x is any antiderivative, because there's a whole bunch you could have. How do you know? If you integrate something, how do you know you did it right? Take the derivative. Then f prime of x has to equal little f of x. That's the fundamental theorem of calculus. It's used quite often. If you go through the grid I gave you, it's used probably maybe 2-3 times on the free response questions. So if they give you an initial condition like 0, 5, if I integrate from 0 to something, I don't know, maybe I want to find out what happens at 10 of f prime of x dx, well, that's equal to f of 10 minus f of 0. But I know what f of 0 is. It's 5. So that's an equation. So it's f of 10 minus 5 equals this integral. Now, you may be using a calculator to find that integral. You may be doing it by hand, or you may be using geometry. And you need to do problems that do that. Solving for f of 10, that would be 5. It's your starting position plus this integral. This is an accumulator. It's accumulating the area under the curve. That's the fundamental theorem of calculus. The minute they give you an initial condition, they tell you one point, and they say, find another one, this is what you're going to do. And it's every time. So if you can recognize those and some free response questions, that's great. Mm-hmm. Yes. If I have, I'm trying to think what that was. 2x plus 3 squared from 0 to 1. If I let u equal 2x plus 3, and they can ask this question on the exam. They'll ask you to set up the integral, but do not integrate it. And your choices will be integrals. Then what's du? 2 dx. So when you replace this with the u substitution, you will have a 1/2 out in front. You'll have u squared du. And remember, all you have is that little list, and it's in that beige packet of the things that you know how to integrate. There's maybe 6 things you know how to integrate. Because if I take the derivative of u, it's 2 dx. Solving for dx, I'll divide by 2 and divide by 2. So dx is 1/2 of du. So I substituted in. But the problem that I've seen you guys do is then you do 0 and 1, and that's going to be one of your choices. That'll be a choice. This will be a choice, integral 0 to 1 of u squared du. This will be a choice. I want to get the right ones. 3 to 5 of u squared du. And they'll have this, 1/2, 3 to 5 of u squared du. So read through them all. If you change this to u, what must you do to your limits? Yes, you must do that. And that on that last test was a problem. So I think I did it right. If x is equal to 0, u is equal to 3. I prefer to make the change and be done with it. I don't like to go back to x's. It takes more work. If x is equal to 1, then u is equal to 2 plus 3 or 5. So I did do it right. They're not going to ask you to integrate it. So my answer is this one. Do you see how they have distractors in there? As needed, probably. The u subs, only thing you know how to integrate is this. You know how to integrate x to the n You know how to integrate 1 over x. This x to the n is for n any number except for what? Except for, no. Well, no, because 0 is just x to the 0, which is 1. I can integrate that. N equal to -1. That's this one. So really, this is your power rule. So I don't care if it's 1 over x squared. It's still the power rule. The only one that's different is this one, which is the log of the absolute value of x. And you must put the absolute value in there. Okay, Katie? What else do we know? We know the sine of x, which gives you negative cosine of x plus c. We know cosine of x, which is what? Sine of x plus c. We know secant squared, tangent of x plus c. We know negative or let's make it positive cosecant squared of x, which is negative cotangent of x plus c. What about secant tangent? This is what you have to get. When you do the U substitutions, you got to get one of these because I know what these are. These are the antiderivatives. What's this one? Secant of x. And I'm putting in plus c in because you got to remember plus c when you do differential equations, or you're done before you start, pretty much. And you have to separate. And you always separate by multiplying, dividing. Mm-hmm. So what's the antiderivative of x to the n? It's x to the n plus 1 divided by n plus 1. Could have changed colors, but anyway, I didn't. What else do we have? Oh, we have cosecant cotangent, right? And you may see these. Well, if secant tangent is secant of x, then what do you think cosecant cotangent is? David, put your phone away, please. Oh, well, I put it all in Schoology. In color. You just have to print it. I put it as PDFs. Everything I've done has always been up on Schoology. Oh, it's not, because if you have to take calculus again, you got wonderful notes. Not really. Okay, what is this? This is cosecant of x, negative cosecant of x plus c. And then we have some other ones. What's this one? Do you remember that one, Austin? Inverse sine of x plus c. If you put a negative there, it's inverse cosine. Just leave it with sine. I don't think it's going to be a problem. Maybe they might do it to you on a multiple choice. Inverse cosine of x. And 1 over 1 plus x squared is inverse tangent. That's it. Those are the only ones you know how to integrate. So I know one on the multiple choice question looked like the integral. Oh, I forgot e to the x. What's e to the x? E to the x. Okay. So if we add e to the tangent of x over cosine squared of x, that doesn't fit anything I have up here, does it? That's one of the multiple choice problems. Awesome. Yeah. Like I said, I'll save it. Or you could bring it up on your computer and take a picture of it. Yeah. Pardon? X to the n plus 1 over n plus 1. The derivative is the other way. You could take the derivative of anything. Well, not the greatest integer function because it's not continuous. But you could take it in pieces. Everything here you need to know. Yes. Yes. It's in your packet as well, that ivory colored packet. Yeah, that one. And I brought some extras in here because I wasn't sure if everybody had one. I'm not sure where mine is. That's pretty much everything you need to know, and the derivatives are on the last page. There they are. I'm sorry, we chapters 2 through 7. Your best bet, Jacob, your best bet is to do the AP problems. Princeton Review, I've seen. I've worked on it with one of my students out in another school district, and it's not nearly as good as the AP problems. It's much more basic, much more like your textbook, and you won't see those kind of problems on the exam. That's the problem. So everything you can integrate has to look like one of these. That's why we do a U substitution. What function do you think that one is that I want to integrate? Carter, what do you think I want to integrate there? You have tangent, you have cosine squared, and you have E. I think it's E. And that's the hard part, figuring out what your U substitution is. If U is equal to the tangent of X, then you try it. Then what's du? What's the derivative of tangent? Secant squared. But what is that? That's 1 over cosine squared. It is tricky, but how do you get better at it? Practice. Yes. And I forgot what it was between. 0 and pi over 4, maybe? Somebody might have their packet. I don't have it. So this is du. So it's the integral of e to the u du. Oh, I know how to do that one. I know what that one is. That's e to the u plus c. And there were limits of integration on that. I just don't remember what they were. Pardon? Yes, it was. What? Okay. Your U substitutions have to make them look like any of these because I can integrate those. There is no product rule. Well, there is. It's called integration by parts. It's not required on this exam, so we're not doing that. Why do something we don't have to do? Okay. That's the first fundamental theorem of calculus. The second one, you will see. She's got Roman numeral 2, but the derivative with respect to x from some constant to x of some function. Now, we use t because I don't want to use x because it's confusing. They're dummy variables. You guys remember what happens there? Sophie, do you remember what happens here? Sophie, what happens to that? The derivative undoes the integral. So it's just what? F of x. You have to know that one. In fact, then maybe we'll do one. See what we're doing tomorrow? Because if you want to know why again, because if you know why, you'll remember it. Let's pretend we could find the antiderivative. Usually you're not going to be able to, but this would be capital F of x minus capital F of a. If I could integrate that. But why integrate something if I'm going to differentiate it back again? Seems like a lot of work, doesn't it? What's the derivative of big F of x? It's little f of x. What's the derivative of f of a? No, that's a constant. It's 0. That's why that's got to be a constant. What if it's in the wrong order? What if we go, we could still do this. That's going to be equal to, if you were to integrate it, it would be f of a minus f of x. So it's minus f of x. We're not on any page. We're on this packet here. Number 2, this one, this gold one. I'm going over these theorems. There's 5 theorems you must know. Then we could do a problem. I easily can find problems that do that. In the last 20 minutes, because that's all you get for time. Seriously. Okay. Mean value theorem, intermediate value theorem. No, we're doing it today. Okay. Yeah, that's okay. We don't get through this. We don't get through all of this. What if I have the derivative with respect to x of the antiderivative of a to g of x? What if it's a function? It may be, it may not be. There will probably be a multiple choice question with this in there and a free response. I'm pretty good at predicting. And this is f of t dt. And if you don't know, you should be paying attention. So it's f of g of x. That's right. So it's f of g of x. But if I were to integrate this, this would be capital F of g of x. When you take the derivative of that composite function, you must remember the chain rule. So it's times the derivative of the upper limit. This works Because what is the derivative of the inside function here? It's 1. What works for that should work. By the way, don't forget to learn your logs. We're not integrating logs, by the way. You need integration by parts to do it. If you get the integral from like 0 to 1 of the log of x dx, that's a calculator problem. Yeah, I'm real worried about our time because we have a whole week in the lab, and maybe we shouldn't spend a whole week in the lab. We'll see what happens by next Friday.
What are we going to do for that?
There's computer software, multiple choice questions and free response questions for you to work. And if you don't understand how to do it, it explains incredibly well how to do it. When you see the software, you'll like it, but they no longer make it. So I can't tell you where to buy it because you can't buy it. I just happen to be lucky and have it. Yeah, it is too bad. Okay. Let's do one little one here as an example. What's the one she's got on here? d dx of negative 1,000 to 3x squared. Now, you can't even integrate this. I can't find a u substitution that's going to do anything for me there. But I don't care. It's the derivative of the antiderivative. What is the answer here, then? These undo. It's ln of what? 3x squared times the sine of 3x squared, right? Times the derivative of the upper limit, which I heard somebody say 6x. That's it. No, you substitute this in for whatever the t is here, and it's times the derivative of that one. Because if you were to integrate that, you would have d dx of capital F of 3x squared minus capital F of negative 1,000, whatever that is. This is going to go away, and then it's f prime of 3x squared times 6x. This is f prime of 3x squared. That's the y. Taylor. This is the second fundamental theorem of calculus. Okay? Those are the really two big ones. Where did I put my other sheet? And we've done the max-min existence theorem. I reviewed that already. Do I need to do it again?
No, but I have a question on top.
Yeah.
You don't always do like this underline thing if you're
You have to figure out whether the derivative changes from positive to negative if you're doing a relative max or min. The number line is an aid. You just find the value. So she's kind of got it right here. She says, if you have a closed interval and you have a continuous function, you are guaranteed a max and a min, and you evaluate your critical points in your function. There's very little calculus. Don't forget that the derivative could be undefined. Okay, I want to get you guys going on your little quiz so you have enough time with it. Tomorrow, we will finish, and she probably will talk about the intermediate value theorem for derivatives and for integrals. And the mean value theorem. And I might, on my iPad, do little lessons on those. It's a matter of finding the time, because I'm behind in my paperwork because I'm here at night. You should. And the study sessions are in the form. Starting at 6, but you don't have to be here at 6. You can come anytime you want. Yes. And then next week, we have 3 nights. Please don't make us come 4. It really is tiring.